We all know AI is getting ridiculously good at creating stuff. Text, images, you name it, even code. But what happens when you try to get a whole team of specialized AIs to build something complex together? How do you stop it from turning into complete chaos? Well, we're about to dive into a pretty cool system that gets an entire AI team to speak one single unified language.
And that brings us to the core problem, right? A single AI on its own might write a perfect little piece of code. But when you ask a team of AIs to build an entire feature, you're risking a total mess. You end up with misunderstandings, a ton of wasted effort, and a final product that looks, well, nothing like the original plan. So how do you actually tame that power?
So how do you wrangle all that potential chaos and turn it into predictable success? We're going to find out by following a really fascinating case study, using a specialized AI team to add a brand new, and yeah, slightly terrifying, mythical creature to a video game.
Alright, so the mission, should we choose to accept it, is to build a drop bear. We're working on a game called 2D Bush Basher, which is this fun off-road driving adventure. And our job is to add a uniquely Australian hazard to make things just a little more interesting for the player.
Now, if you're not up on your Australian folklore, the drop bear is basically this legendary carnivorous koala that, you guessed it, drops from trees onto its prey. Sounds fun, right? So in our game, it's going to be this unpredictable obstacle that lands on the player's car and slows them down for a bit. It's a pretty simple feature, but it's the perfect test to see if our AI team can actually work together.
Okay, let's meet the crew. First up, we have the BMAD agents. Think of this as a specialized AI team, where each agent has a specific job, like being an analyst, a developer, or a QA tester. They all work together on a central platform called Archon, which is kind of their mission control. But the secret sauce, the thing that makes this whole operation tick, is the universal language they all speak, POML. So let's get into phase 1. Before anyone even thinks about writing a single line of code, the team needs a plan that is absolutely rock solid. And this is where this whole system really starts to show its stuff. Think of this part like a perfectly choreographed relay race. It all starts with Mary, the analyst, who brainstorms the initial idea. She then passes the baton to John, the project manager, who makes it official. John then hands it off to Winston, the architect, who draws up the detailed blueprint. The key thing here is that nobody's working in a silo. It's a clear, sequential handoff from one expert to the next. And believe it or not, this whole complex process kicks off with a simple prompt, just like this one. A human asks Mary, the analyst agent, to come up with some ideas. Mary thinks the drop bear is a fantastic concept, looks into how other games have done similar things, and then drafts up an initial brief. And this right here is the absolute game changer. Mary's brief, John's requirements, Winston's technical tasks, none of these are just plain old text documents. Every single one of them is written in that shared, structured language we mentioned. This is what unlocks the power of the entire system. And that language is POML, which stands for Prompt-Oriented Markup Language. The easiest way to think about it is like a super strict set of grammar rules, but for documents that machines need to understand perfectly. It makes sure every piece of information is clearly defined, can be checked automatically, and is totally transparent to everyone on the team.
And the difference this makes is just night and day. Without POML, you're stuck in a world of vague ideas and disconnected documents. But with it, you get formal structured definitions, where everything is linked together and checked automatically. This is what stops an AI from over-engineering or adding features you never asked for. Its work is constantly being checked against the master plan. So check out what the architect, Winston, comes up with. This isn't just some casual to-do list. These are formal tasks. And see that little epic ref tag? That's the POML magic right there. It creates a direct link from this specific task all the way back to the main requirement document. This creates something called lean context, which means any AI working on this task gets exactly the info it needs and nothing else. No more confusion.
All right, the plan is locked in. Not in stone, but in PML, which is even better. Now it's time to actually build this thing. Let's jump into phase 2 and see how the code gets written and, maybe more importantly, how it gets checked. So, a developer agent grabs that first task from Winston's list. But here's the cool part. It doesn't just start guessing or coding from scratch. It taps right into the Archon platform's knowledge base and uses that approved, structured plan to generate the code for the drop bear's detection logic. Okay, but this brings up a massive question, doesn't it? We have an AI writing code based on a plan that was written by another AI. How in the world do you make sure it actually followed the instructions? How do you stop it from making the mistake or just hallucinating a feature that was never part of the plan?
The answer isn't to just throw a human at the problem, at least not right away. It's all about automated quality gates. Because everything's written in Pommel, the system can automatically check the AI's work against a predefined rulebook, which is called a schema.
And here's what one of those quality gates actually looks like. This simple file basically lays down the law for our drop bear. It says there must be a detection range, and it has to be a whole number. There must be a fall speed. But you'll notice damage amount is optional. So if the dev agent writes code but forgets one of these required parts, bam, the system flags it as an error automatically before a human even lays eyes on it.
This is where our QA agent Quinn comes into the picture. And honestly, this system makes Quinn's job way better. Before Quinn even gets the code, Archon has already run all its automatic checks. So if the dev agent forgot to include the debuff duration, the code fails that quality gate immediately. This means Quinn can stop hunting for simple mistakes and focus on the really tricky, complex stuff. The result is just faster, more reliable, and way more consistent QA.
So, there we have it. Our drop bear is successfully planned, built, and validated. But the real story here, the big takeaway, isn't just about one scary koala. It's about a whole new, structured way to get AIs to collaborate effectively without driving each other crazy.
The Archon platform is really the command center for all of this. It gives you a visual of the entire workflow, manages all the tasks, and, crucially, provides that lean context we talked about. By making sure agents only get the information they need for the job at hand, it cuts down on errors and confusion like you wouldn't believe.
So when you put this all together, what do you actually get? Well, it creates a development process that is way more predictable and totally transparent. When everyone, and I mean both humans and AI, is speaking the same structured language, you can see exactly what's happening at every step. And that all adds up to better efficiency and a whole lot fewer errors. And that leaves us with one last big idea to chew on. We used a fun little video game example today, but just imagine for a second, what if you could apply this same level of structured, machine-validated collaboration to much bigger problems? What if building complex software, or conducting scientific research, or managing massive engineering projects had this same level of built-in clarity and control? Now that is the truly exciting future that an approach like this points towards.